Hello at-home scientists and welcome back to Echo Live, coming to you from the Michigan Science Center. We have a very special program planned for today all about the moon. Today we're celebrating, or over the weekend we celebrated a pretty important anniversary in science exploration history, specifically in space exploration history. Today we'll be talking about the famous quote, Houston, we've had a problem. So to talk to us a little bit more about this quote, to talk to us about the moon and the history behind it, we'll be joined today by our staff astronomer and solar system ambassador, Paulette Epstein. So thank you so much for joining us. Paulette, how are you today?
I am excellent. Thank you so much for having me today. So, like you said, we're going to be talking all about the moon today. But before we do, I want to talk a little bit about the Apollo 13 mission. So, like you said, Apollo 13 was launched on April 11th, and that was 1970. So, that was 50 years ago this past weekend. We're really excited to be celebrating Apollo 13 because it is known as one of our successful failures. So, on April 13th, 1970, so 50 years ago today, the astronauts had an issue with their oxygen. So their oxygen tank exploded. And so that's where Houston, we've had a problem comes from, is they actually called back to mission control and said, hey, Houston, we've had a problem. Our oxygen tanks have basically exploded. So with some cunning engineering and people back at Mission Control, they were able to fix or not fix the tank, but come up with a solution so that they could get back to Earth safely. Unfortunately, they weren't able to land on the moon, but we were able to land on the moon just a couple of months prior in Apollo 11 and Apollo 12.
Very cool. So we've got a really awesome program planned for everybody. If you haven't done so already, please introduce yourself in the chat, either here on Zoom or through our Facebook live stream. We've actually started streaming live to YouTube as well. So if we do have anyone joining us on YouTube, thank you for joining us. We love that we can bring this to you at home on so many different platforms. So introduce yourself in the chat, and remember that the chat feature is your best way to communicate with Paulette throughout the program. We'll be stopping for questions periodically throughout the program. And I know Paulette also has a lot of really good questions to ask you. So if you'd like to answer any of those questions, make sure you type up your answers in the chat, and we'll pause throughout to take some of your questions and comments. So with that, I'll let Paulette take it away.
All right, so we are going to go back into our virtual planetarium. Now, this planetarium that we're using today is actually a different software than we've been using in previous programs. This is something called OpenSpace. This is also a free program, but this one is a little more complicated to use than Stellarium, the program that we had been using. So right here we have the moon in front of us, and the moon has some really interesting features. It has these bumps on the surface right here and these dark spots over here. So when we're looking at the moon, can anybody tell me what are these spots right here called? They are caused by meteors and meteoroids and asteroids hitting the surface of the moon. But what are these things called that we find on the surface of the moon? Go ahead and type it in the chat if you know what these things are called. Yeah, we have some people popping up saying that these are called craters. That's right. These are craters that we see on the moon. These are because the moon doesn't really have much of an atmosphere to protect it from getting bombarded by small asteroids, and there's no erosion or weather to wear away the surface. So once a crater is there, it's there until something else hits it. It also has these dark areas that we see called mare. They used to think that these were oceans of liquid water. But does anybody know, is there water on the moon? They used to think they were oceans of liquid water, but look really closely on the image that we have here. Do these look like oceans to you, or do they look like something else? Is there water on the moon? Is there water on the moon? And I see somebody said, no way. That's right. There is not any water on the moon, or at least not on the surface. So these are not giant oceans. And if we actually zoom in a little bit and get a little closer, we'll be able to see that these are just darker areas. So these are what we call maria for plural, and singular is mare. When we look at the moon, we'll be able to actually see some of our landing sites. Now, we have landed on the moon a couple of times. Does anybody know how many times we've landed on the moon? I've already mentioned Apollo 11 and 12, and we also said that Apollo 13 didn't land on the moon. Does anybody know how many times we have landed on the moon? And this is a really tricky question. Let's see. I'll give you a hint to this question, and I'll actually just go ahead and show our Apollo landing sites. Again, how many times have we landed on the moon? 12, that's a really great guess. We also say 2 or more, also a fantastic guess. We've definitely landed on more than twice. We have, and someone's got it, 6 times landed on the moon. So we have Apollo, let's see, Apollo 11. We have Apollo 12. Let's see, we have, so 13 didn't land, but 14. And then we have 15, 16, and 17. We have landed on the moon, that's right, 6 times. We were supposed to land on the moon actually 8 times, but Apollo 18 never went, and Apollo 13, like we know, never got to the surface. So we have all of these different areas, and you can see that we tried to land in areas that were different and had different geology. So if we look at Apollo 11, right there, we actually landed someplace called the Sea of Tranquility. So let me get rid of these labels for just a second. The Sea of Tranquility, which is right over here. So we landed for the first time on the moon right about there, and we were able to find out a lot about the geology. If we look at some of the other spots that we landed, like this one right up over here with Apollo 17. This one, we actually tried to land in one of the mountainous areas. So we were trying to learn a little bit more about the craters and some of the geology that we might see there. Now, we said that there's a lot of maria or mare on the surface of the moon over here. And this is the side of the moon that is always facing us on the Earth. And the moon is something that we call tidally locked, which means that we don't always see the same side of, or we always see the same side of the moon because it rotates at the same speed that it revolves. So if we look, so this side right here is the side that we're always facing. And as you saw, all of our missions landed on this part of the moon. But if we actually go over to the other side of our moon, we'll be able to see that it doesn't have any of those maria or those dark areas on the surface. So that's one thing that we're sort of trying to experiment and explore right now to learn a little bit more about how the moon formed and what is happening to it throughout time. So let's see, we have somebody who wants to know, why is the moon a circle? That is a fantastic question. So it's a sphere, kind of shaped like a ball. As we go around it, we can see that a little bit. So we're actually flying through space here and flying to see the other side. I'm trying to go a little bit slowly so we can see it a little better. And it is shaped like a ball because of something that we call hydrostatic equilibrium. So the moon is big enough that it compresses down on itself. And the easiest shape for it to be is actually a sphere or a round shape. That's why you'll notice that the planets in our solar system are also round. And it's because of that hydrostatic equilibrium. It's because everything on the outside is pushing down on it and pushing down on it evenly because of the gravitational force. We also have someone that says, are craters permanent? Really, really great question. So the answer to that is yes and no. Craters are not necessarily always permanent, but once they're there until something else comes in and bashes into the surface. So for example, this crater right here will always exist until something else comes in and hits it again. And we'll talk a little bit more about how craters are formed a little bit later on in our program today. But yes, craters are always, they're pretty much always the same, but they can change depending on what is hitting it. Let's see. And does the moon rotate around itself like the planets? Yes, it does revolve. It revolves on its axis it rotates on its axis as it revolves around the Earth. It just does it at the same speed. That's why we always see the same face. And does the moon have a north and south pole like the Earth? Really, really great question. And the answer is kind of. So the moon doesn't really have much of a magnetic field around it, and the Earth does. The Earth has a huge magnetosphere, and that magnetosphere can actually tug on a magnet or a compass. So that's how we can see the north and south pole of the Earth. It does have a rotational axis going through it, but not necessarily a north pole and a south pole, because it's not going to tug on a magnet to give you those directions. So the answer is yes, it has a rotational axis, but we don't necessarily call them north and south poles, even though technically they would be. Let's see. Okay, so someone asked, why is there no water on the moon? And that's another really, really great question. And it's really because there isn't much of an atmosphere on the moon. The atmosphere is very, very thin, so not a lot of air to hold anything in. So there's no air to hold in any water. We have actually found water underneath the surface of the moon, but nothing on top of the surface, at least not yet. So there is frozen water, but it's underneath the surface. It's not on top. All right, so we have some really, really great questions coming in. So here we have, like I said, our moon with the Maria, the craters, and oh, that's a really great question as well. So we do have some folks asking, how did the moon get into space? And I think I saw somebody else ask, was the moon part of the Earth at one time? So there are a couple of theories out there, and some of those theories are that a giant asteroid came in and hit the surface of the Earth when it was still forming. So what happened was that asteroid took off a piece of the Earth and pushed it out into space and fell into the Earth's gravitational orbit. And that's what became the moon at some point. So that's one of the really interesting theories about how the moon has been created. But there's also other theories out there as well. Now, somebody asked, has there ever been life on the moon? Well, let's see. You tell me. We've gone to the moon 6 times. So has there ever been life on the moon? Ever been life on the moon if we've been there 6 times? Really great question. We've been there 6 times. Ever been life on the moon? Of course. because we've been there 6 times. So there was life on the moon when we were there. There is no life on the moon now, however, but the only life has been us when we are there, but we're not native to the moon. Somebody else asked, did we ever go all the way around the moon? And that's a really, really fantastic question because yes, and that's actually how the Apollo 13 astronauts got back to Earth. They were on the way to the moon and they were past the point of no return. So they had to continue to go on past the moon. They were actually able to take items from the LEM, or the lunar lander, the items from the command module, and they were able to get back to the moon, or get back to Earth, because they used the gravitational force of the moon to bring themselves back and around to get back to the Earth. So really fantastic questions. And we also went around the moon during Apollo 8. So Jim Lovell, who was part of the Apollo 13 astronauts, also was part of the Apollo 8 astronauts. So he actually never really got to step on the moon, even though he went around it twice. All right, so you might be wondering, how are these craters on the surface formed? And some of these craters look different than others. So let's go ahead and take a look at a crater. Let's take a look at this crater right here, and we're going to take a little bit of a closer look at it. So we're going to zoom on in and we're going to take a closer look at one of these craters that we can see. All right, now craters are caused by impacts from larger objects in our solar system, so from asteroids or meteoroids, and they are basically just impact sites of these things that are hitting it. So if we look at the structure of a crater, we can tell if it's a simple crater or a complex crater by taking a closer look. So when we look at this one right here, we can see down here where it's been hit by that object, we've got fractured bedrock, impact melt, and when we look out this way, we'll actually be able to see something that we call ejecta. So that's when the stuff that's inside the crater at once kind of gets pushed out and it bounces out and goes all around. That is what we call ejecta. So we have those, a simple crater right here with the fractured bedrock in the crater and all of the ejecta around it. Now, we also have a crater over here that's a little bit more complex. So this is something that we call a complex crater because it has this little bump right here in the middle, and that's actually a peak that has been created because of that forceful impact on the moon. So we can see that, that central peak uplift right here. All right, so we've got our fractured bedrock here. We have our edges of our crater, and we can see some ejecta here as well. Now, if you're really interested in craters, you can actually do an activity at home as well. So I am going to, let's see, I'm going to show everybody an activity that you can do at home. Let me just switch my cameras here for just a second so that I can show you this activity a little bit better. And There we go. We can see our, this is actually flour and cocoa powder on top. So let me stop our screen share here so that we can see that a little bit better. There we go. We have flour underneath and cocoa powder on top. So for this, we have sort of our two layers of the moon. We have the layer underneath, which is the older material, and then we have our layer on top, which is the newer material. And if we take an object, like this one right here, and we drop it onto the surface of our moon, we'll be able to see what happens. So let me go ahead and drop this object, and we can see what happens to the surface of our moon. All right. So if we look a little bit closer at this, we're going to be able to see it's a pretty simple crater. We have it where it went through the surface. We have a little bit of that white ejecta along the outside. Let's try a different object. Let's try a different marble. So I've got one right here, and see what happens to it. Oh, that one was a pretty good one, although it went pretty smoothly through. So let's see if I do an even larger object, what's going to happen. So let's use our hypotheses. If I use a larger object like this giant marble right here, what do we think is going to happen when we compare that to the other two that we did? We did a rock right here, and we did a marble right here. So we're going to use our scientific method, and we're going to make a hypothesis on what's going to happen with our marble right here. Go ahead and type it into the chat if you have a hypothesis compared to, or an educated guess compared to our rock and our other marble. What do we think is going to happen? Do we have any guesses? What do we think is going to happen? More impact, that's a really great guess. All right, so bigger crater, more impact, fantastic. A more complex crater, that's a really great guess as well. All right, we've got my marble. Now we're gonna drop it in 3, 2, 1. Ooh. All right, so when we take a look at this one, we actually had a lot of ejecta get thrown off for this one. We can see a lot of that material right over here, and that's very similar to the craters that we saw on our virtual planetarium. So with that, we can see the ejecta there, the ridge right there, and if I pull this out, we actually do have a little bit of essential bumps in this one. It did also make a louder noise, that's right. It actually hit the bottom of my pan that I'm using. So this is something that you can try at home with different sized objects. Make sure to ask your parents first. But like I said, it's just a pan of flour and cocoa powder. So you put the flour down first and the cocoa powder on top. And who knows, depending on how much flour and cocoa powder you use, you might be able to make cookies when you're done. Just make sure that the marbles are washed before you do it. And you're right, it did cover up the other craters. Now, somebody had asked me, are craters permanent? Well, this is how I said, you know, kind of, but not really. So when another object came in and dropped in the same spot or near it, it covered up the other craters. So that's a really, really great way of showing how craters are there for the most part, but not always the most permanent. So let's go ahead and go back to our virtual planetarium right here so that we can see our craters again. Now that we were able to look at the craters with the flour and the cocoa powder, we can see a little bit of a difference or we might be able to see a better example of some of the ones that we see. Now, somebody asked, how big are craters? And that is a fantastic question. Craters are as big as the object that is around them. So, or that causes them. For example, if we had a really big object, say an asteroid or something like that, hit the surface of the moon, it's going to create a much larger crater like this one right here. And that's actually how they think that these Maria formed a long time ago, was that a really massive object came in and hit them and actually caused some of the lava inside of the moon to come up and make these darker areas that we see. At this point in the moon's life, the objects that are hitting it are much smaller. So these craters are going to be much smaller. Let's see. We also, if we look at some of the questions that we've gotten, so somebody asked, why is the moon gray? And that's a really, really great question. And the moon is gray because that's the color of the rocks. So the materials that the moon is made out of are mostly sort of that gray color. And they actually reflect a lot of sunlight back to us on the Earth, which is why we can see the sun, or the Earth. It's why we can see the moon up in the sky. So we've got, so most of the materials, like I said, are gray, but if it were made out of a different material, like Mars, it would be a different color. So if it were a different material like iron oxide or rust in the soil, then it would be reddish in color, just like our planet Mars that we had in our solar system. Let's see, we have another really great question about how big is the moon. So when we compare the moon to the Earth, the moon is about a quarter of the size of the Earth. So you can fit about 4 moons inside of 1 Earth. So really fantastic question. Liam wants to know how the craters and asteroids get out of the craters. Really great question. It doesn't. Most of them just kind of stay there, but they break up on impact. Just like, except for, so we are using objects that of course are made out of glass or other materials. They're not going to break up on impact, but something like an asteroid, which is a relatively loose collection of rocks, will break up on its impact. Let's see, we have another fantastic question. Are all the moons in our solar system gray? Which is like I said, really fantastic question. And the answer is no. Not all of the moons in our solar system are gray. Some of them are gray. Phobos and Deimos are mostly gray. But there's also some of our Galilean moons, Io, Europa, Ganymede, and Callisto. Those 4 moons, none of them are gray. One of them kind of looks like a pepperoni pizza because it's got volcanoes on the surface. Another one kind of looks like it's kind of a bluish color because it has ice on the surface. So not all of them are gray, basically just ours because of what it's made out of. Let's see. Has a meteor hit the Earth? I love this question. So we're going to think about meteors and whether or not they've hit the Earth. So we have a crater on the Earth called Meteor Crater, and that is where a meteor hit the Earth a really, really long time ago. We've also had meteors hit, once they hit the Earth, they're actually called meteorites. When they're in space, they're meteoroids. When they're flying through the air, they're meteors. When they hit the ground, they're meteorites. But we have had meteorite that caused a ginormous crater. We also had some meteorites actually on the surface of the Earth just about a year ago or so. There was actually a giant meteor that exploded over the state of Michigan, and pieces of that actually fell to the Earth. So I believe that you can see some of those on display in Flint when their museum does open back up. So meteor crater, yes, that was in Arizona. So, all right, we've had some really fantastic questions. Do we have any others? Anna, have you seen any really good ones?
I think you've done a pretty good job of answering the ones that I've pinned so far, and I think we are just about out of time for our ECHO program today. If you do have any last questions, please still send them in the chat. We are so glad that you are all sending in such great questions and answering Paulette's questions. We are going to, at this time, as always, we're going to thank our sponsors of the Michigan Science Center. We truly enjoy bringing these programs to you for free every weekday at 2:30 p.m. Eastern. Our sponsors like the DTE Energy Foundation keep the Michigan Science Center up and running even while we are closed to the public. So we are very, very thankful to all of our sponsors and our individual donors like all of you at home who are tuning in, watching these programs, and giving us such positive feedback. As always, if you'd like to be notified when we go live every weekday, make sure that you are liking the Michigan Science Center and following us on Facebook as well. These programs are streamed through Zoom, through Facebook Live, and now also through YouTube Live. And so you can watch us and interact with us live on any of those platforms. So let's see if we can check back on the chat. Paulette, do you see any good questions in the chat?
I do. I see one more fantastic question that I can answer before we end for the day. Somebody says, does the moon control water on the Earth? And that is a really, really fantastic question. So the moon does kind of control the water on the Earth. All of the objects that have mass or that have weight, well, scientifically it's mass, they have gravity. Gravity is a force that pulls on other objects. So the Earth has gravity, which is what keeps us on the surface of the Earth, but there are also so there's gravity from the Earth, there's also gravity from the moon. And that gravity from the moon actually tugs on the Earth's oceans and causes the tides that we see. So high tide and low tide are actually caused by our Earth's moon. Fantastic question.
All right, that's just about all the time we have for ECHO Live today. We hope we'll see all of you back here tomorrow at 2:30 p.m. Eastern for another episode of ECHO Live. Thank you so much, Paulette. Paulette is going to keep an eye on those comments, so if you do have questions that we haven't yet answered, you can still type them in the chat even after our program ends. You can send us a message, and Paulette will keep an eye on those to make sure that we get you answers that you are looking for. So thank you so much, Paulette, and we'll see everyone else tomorrow at 2:30. Bye, everyone.
Bye.